Namaskar. In this series, we shall discuss RS flip-flop, then gated flip-flop, ACE trigger flip-flop, D flip-flop, JK flip-flop, and master and slave flip-flop. That is chapter number 2. Now, as a prerequisite, we shall discuss something about the NOR gate. Correct? We are aware about NOR gate. Logic gate is the electronic circuit in which the output is the logic function of input. So, what is NOR gate? The symbolic representation of NOR gate is something like this. This is two input NOR gate. If A is the input, B is the input, and Y is the output, then the logic equation is that Y is equal to A plus B bar. A plus B is the OR, and if I take complement of that is bar, then we can write Y is equal to A plus B bar. This is the NOR gate. How can I write the truth table? This is input, output. Input is A, B, output is Y. There are four possibilities: 0, 0, 0, 1, 1, 0 and 1, 1. In case of not of OR, that is NOR gate, if both inputs are 0, 0, then the output is 1, and otherwise it is 0, 0, 0. See, you will realize that if it is OR gate, then for these three inputs the output is 1, 1, 1. But we will have to complement it, and therefore this is the truth table of NOR gate, right? Similarly, we will have to discuss something about the NAND gate. The NAND is not of AND. So I will have to draw the AND gate and make the not of AND. Therefore, this is the symbolic representation of two input NAND gate. And I can write here it is A dot B, this is and I will have to make the not of that. Therefore, this is the logic equation for NAND gate. How can I prepare the truth table? These are the inputs A and B. This is output, it is Y. Again 0, 0, 0, 1, 1, 0 and 1, 1. Now for AND gate, when both input are 1, 1, then only there is output is 1. But I will have to make it not. So here I will write it is 0 and then here it is 1, 1, 1. Okay. Now this is NOR gate and this is NAND gate. This prerequisite for beginning of flip-flop. Now if I define the logic gate, there are several logic gates. NOT gate is there, AND gate is there, OR gate is there, XOR gate is there. In general, I can say that logic gate is the electronic circuit having several inputs and a output, single output, where the output Y is the logic function of all inputs A, B, C and so on. Suppose there are number of inputs, then the output should be a logic function. What is meant by logic? There are generally three logics. One is a NOT, and OR. And then we can have the combined logic like this. This is not of OR, so NOR. Not of AND, so it is NAND. We may exclude some case and we may have the XOR gate, XNOR gate, etc. And that we have discussed in first year. How can I define a flip-flop? Typically, flip-flop is the electronic circuit having two outputs which are complement of each other. That means if one output is said to be Q, the other is Q bar. Therefore, it is expected that if Q output is 0, then Q bar should be equal to 1. If Q is 1, then Q bar should be equal to 0. This is expected. Okay. Now typically a flip-flop may have 3 inputs. I am calling it as it is may have. It depends on which type of flip-flop we are discussing for. Out of these 3, one is definitely clock if it is present, and it may happen that there is no clock. We will have to begin with that. Another may be R, J or D or T, etc. And accordingly the other input may be S, K, and there is no need of input in case of D and T. Therefore, it may happen that there is RS flip-flop, one input is R, other is S. There is JK flip-flop, one is J, other is K. There is D flip-flop, only one input is there, no need of other. There is T flip-flop, only one input, there is no need of other. Clock is optional in some flip-flop. If it is clock flip-flop, then clock input is there. The clock input may be level trigger or it may be age trigger, and we will have to discuss this stepwise. Okay, therefore generally I can say that the flip-flop is the electronic circuit having 2 outputs complement of each other. There is no description for input, it depends. Now what I will do, I will draw a circuit with NOR gate, and then you will realize that how this circuit behaves as flip-flop. Okay, now this is a circuit. Now I will call this as gate 1, this is NOR gate, this is gate 2, and now what I will have to do, I will have to prepare a truth table. I will call this as Q, and I will call this as Q bar. But as there is feedback check, the present status of output depends on the present input and the past output. What is the previous output? It depends on that. Now, in case of the encoder, decoder, simple logic gate, adder, etc., we have observed that multiplexer, demultiplexer, we have observed that the output depends only on the present input, and that is known as a combinational electronic device. Whereas if the output depends on the previous output, that means if there is a feedback, see here there is a connection between a output and an input. This Q output acts as input for the second NOR gate, whereas Q bar output acts as input for the first NOR gate. If it is so, then such a circuit is known as sequential circuit. Why we will call it as sequential circuit, we will discuss afterward when we discuss T flip-flop typically. Okay, toggle flip-flop. Then you will realize that why it is called as sequential electronic circuit. And in that case, it is better to write Qn, that is what is the present nth. Here I will write Qn. And what will happen if I consider Qn minus 1, then it is the previous state output. Therefore, this is the current state output, and if I write Qn minus 1, then that will be the previous state output. Now with this background, if we try to prepare the truth table for this circuit, then I will write here it is R input, S input, these are 2 inputs, and output, here I will write it is Qn output and Qn bar output, correct? They are complement to each other. It is according to the definition of flip-flop, and so I will have to write Qn and complement of that it is Qn bar. Now as always in case of flip-flop, second output is complement of the first one, so there is no need to write this, just you can write Qn only. But here in case of the RS flip-flop, we will have to mention that Qn, with some specific purpose. What is the purpose we will discuss after some time. Okay. Now what about the inputs? This input is R input and this is S input. Now what we will have to do? We will have to prepare the truth table. Obviously, as there are two inputs, then there are four combinations beginning from 0 0, then it may be 0 1, then it may be 1 0, and I will have to write it is 1 1. Now why I have kept some space here? There is specific reason. We will discuss this after some time. Now if both inputs are 0 0, now you have to decide what is the output Qn and what is the output Qn bar. Now it is interesting. This is 0, this is 0. Therefore you will observe that in case of a NOR gate, if one input is 0, then the output depends on other. Check. If one input is 0, then the output depends on others, and it is complement. That means if B is 0, then the Y is 1. If B is 1, then Y is 0. And so, if R is 0, Qn depends on other input, which is Qn bar. Right? So, if Qn bar is equal to 0, then Qn is 1. And if Qn bar is equal to 1, it is previously 1, then you will observe that it becomes 0. And if it is 0, it is 1. As it is 1, it is 0, therefore it maintains the state. It maintains the state and it depends on the previous state. What is previous? Qn, that is Qn minus 1, previous. And here I will write it is Qn minus 1. What it indicates? Now the output is the previous output. If previously it is 0, it remains 0. Check. If it is 0, I will write here it is 0, this 0 is here, both are 0 0, so this is 1, this one is here. At 0 1, it is 0. Therefore, it remains 0 and 1. It remains 0 and Qn minus 1 bar. But suppose previously if it is 1, that means Qn minus 1 is 1, you will observe that here it is 1, 0 1, it remains 0. This 0 acts as input, and if it is 0 0, it remains 1. Therefore, it remains as it is. And so, I cannot write definitely it is 0 or definitely it is 1 and definitely it is 1 and this is 0. It remains as it is, and this is represented by Qn minus 1 and Qn minus 1 bar. Correct? You will have to understand this precisely, bit carefully. I will explain once again. If R and S are 0 0, then the value of Qn depends on previous value. If the previous value is 0, it remains 0. So I will have to write it is Qn minus 1. If previous value is 1, it remains 1. And again I will have to write Qn minus 1 previous value. Right? Fine. What happens if R is equal to 0, second case, and S is equal to 1? Now if one input is 1, any one input is 1, then irrespective of second, output is 0. And so we will have to focus on S to be equal to 1. If it is 1, irrespective of Qn, what is Qn? Forget about that. The output Qn minus Qn bar will be 0 because this is 1. If one input is 1, output is definitely 0. And so, if S is 1, definitely Qn bar is equal to 0. Qn bar is equal to 0. Now as this is 0, it acts as a input for first NOR gate. So now both the inputs of NOR gate are 0 and output Qn is 1. Check. Right? It will not depend on the previous value. It will be forced to be equal to 1. Qn is forced to be equal to 1 and Qn bar is forced to be equal to 0, irrespective of the previous value. Right? Similarly, suppose R is equal to now 1, R is equal to 1 and S is equal to 0. Now we will have to focus on R because R is 1. Hence, irrespective of Qn minus 1 bar, now Qn becomes 0. Now this 0 acts as input to the second NOR gate. Both the inputs of second NOR gate are 0 and hence the output is forced to be equal to 1. It is forced to be equal to 1. Right? Therefore, these two cases are similar. And now the last combination, possible combination, if both are 1, 1. Now what will happen? If this is 1, therefore R input to first NOR gate is 1. Hence Qn is forced to be 0. And as S input to the second NOR gate is 1, Qn bar is forced to be 0. They are forced to be 0. Because of this, if any one input is 1, 1, any one, this is 1, or both are 1, output is 0. And so they are forced to be equal to 0. Right? But according to our definition, in case of flip-flop, output should be complement of each other. Here the condition is satisfied. It is Qn minus 1, that is previous output. Qn minus 1 bar complement of previous. Therefore both are complement of each other. Here they are complement of each other. Here they are complement with each other. But here they are not complement of each other, and so it is known as illegal state, because it will not satisfy the definition of flip-flop. And in case of RS flip-flop, it is not a pure flip-flop. For the last state, it will not work as a flip-flop, and so it is illegal state. What happens here? Here the output remains as it is, and so I will call this as it is. There is no change in the output. Here what happens? It gets set. Here it is set. Therefore this input is known as set input. This is known as reset input, and Qn gets set. Therefore this state is known as set state. Obviously this is known as reset state because the output becomes 0. Right? And this circuit behaves as RS flip-flop. Now can you replace this NOR gate by NAND gate and prepare similar truth table? Let it be homework for you. Next time we will discuss with that. Thank you.